This is Sung, and I'm the Principal and Director of Sky Academy. And in this particular episode, we'll be continuing the work we've been doing on plane geometry, and we'll be looking specifically at what happens on parallel lines. Now, parallel lines are lines that kind of go in the same, well, not kind of, they do. They go in the same direction, and they go continuously in the same direction, and they won't cross each other because they do go in the same direction. They'll always be the same distance apart, and they'll keep moving without crossing each other. Okay, that's parallel lines. You can also have parallel rays and parallel intervals as well. Okay, so as long as they're going in the same direction, all right, you can say that they're parallel. Now, when we kind of show that two lines are parallel by putting an arrow on both of those lines, okay, to show that this line goes in this direction and this line goes in the same direction. The arrow, that's what the arrows indicate, all right? Sometimes on parallel lines, you will have a line that cuts through it, okay? And in particular, with problems to do with parallel lines, you will usually, like 99% of the time, have a line that cuts through it, and that line that cuts through it will cut through both lines. That line is called a transversal, okay? So parallel lines are denoted by arrows, all right? A transversal is a line that cuts through the parallel lines, so that's called a transversal. All right, and that brings us to the axioms, all right? There are three axioms, one to do with corresponding angles, so corresponding angles on parallel lines are equal, alternate angles on parallel lines are equal, and co-interior angles on parallel lines are equal. Now, if we've got these three axioms, we need to understand what these three words mean, okay? So corresponding angles, what are corresponding angles on parallel lines? Corresponding angles are angles that there are two angles that form together to make an F shape, right? So see how in this particular pattern, this angle and this angle form to make an F shape. We can say that those two angles are corresponding. And they will also be corresponding if they make a back to front F shape, an upside down and back to front F shape, or an upside down F shape as well. They're still corresponding angles. And the thing with corresponding angles is that corresponding angles on parallel lines are equal, okay? Which means this angle G, in the part of the angle where G lies, is corresponding to this one where the F lies. These two angles are corresponding. They're both on parallel lines. So the axiom tells us that we can assume that those two angles are equal. These two angles are also equal for the same reason. These two angles are also equal for the same reason. And these two angles are also equal for the same reason. So you need to be able to recognize corresponding angles, right? And once you do, and once you know that those corresponding angles sit on parallel lines, you can use this axiom to say that corresponding angles on parallel lines are equal. You can do the same thing for alternate angles, but you need to be able to recognize what alternate angles are. Alternate angles make a Z shape, all right? And here are all the ways that you can recognize that Z shape. You can be there and there. It can be a back to front Z, there and there. It can be a funny Z shape that kind of looks like that, right, where the two angles are obtuse, and the back to front version of that, okay? So that kind of follows on from the fact that corresponding angles are equal. So if these two angles are corresponding and they're equal, then you can, by vertically opposite angles, which was the axiom before, we can know that this angle is equal to that angle, which means that these two angles, these two angles are also equal, which we can now say are also alternate. Okay, so we can say that alternate angles on parallel lines are equal as well. Does that make sense? So we've done corresponding angles make an F shape, alternate angles make a Z shape, and the last one, co-interior angles, make a C shape. And not just the C shape, but a back to front C shape, right? Like this, or a back to front C shape like this. Okay? So they're the orientations, or they're the ways that you can make a C shape. Okay? Alright. Cool. And now with co-interior angles, the thing with co-interior angles is that they make 180 degrees. And the reason why we can say that is these two angles here will make 180 degrees. These two angles are equal. This angle and this angle will equal to 180 degrees. Therefore, this angle and this angle will equal to 180 degrees because these two angles are the same. Okay? So co-interior angles are what we call supplementary. They're equal to 180 degrees. We will be doing some problems that have to do with using these axioms later, but I just want to introduce you to that now. Okay? So I'll stand to the side, you can have a look. Alright, and I'll see you in the next episode where we'll be doing the next axiom.